What if I told you the world's greatest engineers aren't human? Forget skyscrapers, forget bridges, forget our so-called marvels of modern architecture. Because right beneath our feet, there exists a hidden world of sprawling underground metropolises, built not by us, but by ants. These colonies are no mere tunnels, they are functional cities, complete with ventilation shafts, nurseries, food storage chambers, even fungal farms. And the most astonishing part? They're all built by creatures you could crush with your thumb. Prepare to have your mind blown as we dive into the incredible, uncredited architectural genius of ants. Every year, ants move an estimated 50 tons of soil per acre, aerating the ground, reshaping landscapes, and changing ecosystems in ways we barely notice. Multiply that by millions of colonies across the globe, and you start to realize just how vast their impact really is. But here's the thing, ants don't just move dirt randomly. Their colonies are carefully designed, serving as some of the most complex natural engineering projects on Earth. What looks like a small mound at the surface is actually the tip of an underground empire, stretching meters deep with labyrinth-like corridors that rival anything humans could design. And yet, we walk past them every day, blind to the engineering marvels beneath our very feet. Let's descend into these miniature metropolises. Inside an ant colony, everything has a purpose. Ventilation shafts circulate fresh air, preventing suffocation in densely packed chambers. Moisture control rooms regulate humidity, protecting delicate larvae and fungal crops. Storage chambers hold seeds and food, organized by type and accessibility. Some species even build fungal farms, cultivating their own food supply like expert agricultural engineers. This isn't random digging, it's strategic, optimized construction. In fact, scientists once poured liquid cement into abandoned colonies, and after excavation, revealed networks sprawling as large as entire human houses. What appeared on the surface as a small anthill turned out to be a city beneath the soil. Their architectural precision isn't just survival, it's resource management, environmental control, and community planning, all without blueprints or a single architect in charge. So how do ants pull this off? How do creatures with such tiny brains achieve what looks like organized genius? The answer is swarm intelligence. Unlike humans, ants don't follow a master plan. Instead, each ant follows simple rules, guided by chemical signals called pheromones. An ant might dig when it smells a trail, stop when it feels vibrations, or deposit soil in response to temperature shifts. But here's the magic. When millions of ants follow these simple rules, complex patterns emerge. Entire ventilation systems form naturally. Chambers take shape. Highways of tunnels appear, not by central command, but through collective cooperation. It's the same principle behind algorithms that power the internet, GPS navigation, and even modern robotics. In fact, engineers today study ant behavior to design self-organizing systems, from delivery drones to disaster rescue robots. What looks like chaos to us is in reality the blueprint of collective intelligence. But ant engineering isn't just about ants. Their construction reshapes entire ecosystems. By tunneling and moving soil, they aerate the ground, improving water infiltration and nutrient cycling. Their discarded soil piles fertilize plant growth, and in many forests, ants act as gardeners, carrying seeds underground, unintentionally planting and protecting them, ensuring the survival of countless plant species. Their colonies create microclimates where other insects and organisms can thrive. In essence, ants are ecosystem engineers. Without their constant digging and moving, the soil beneath our feet would be less fertile, less alive. They may be small, they may be overlooked, but their work is monumental. And once you understand the scale of their genius, you'll never look at an anthill the same way again.